Okay, so let's take a look at the following situation. Here's a function. Point A, point B. And let's say that this is the line segment connecting these 2 points. Let's suppose I'm interested in the average rate of change of the function. Of course, this is our A comma B. And if I ask you, please give me the slope of this line or the average rate of change, what will you say? It's so much easier for me to stand in front of you than sit. I can't sit for this long. Can anyone give us the slope of AB or the average rate of change?
It would be B minus B over A minus A. I'm sorry. No.
Of course, my apologies. This is f of x.
It would be delta y over delta x.
Perfect. So it will be f of b minus f of a over b minus a. Very good. Okay, so here's what I'm going to do next. I'm going to draw a parallel to lines segment AB that is tangent to the graph. At a point, and let's say, of course, you already know. So the mean value theorem has 2 hypotheses. Number 1 is f is continuous on A comma B. Would you agree? Good. So an f is differentiable on at least the open interval A comma B. No other hypothesis here. Then by MVT, there exists at least a C in the open interval A comma B such that, can anyone give us the slope of this line?
It's f of b minus f of a over
Excellent.
b minus a.
Very good. And there is another way. This is with algebra. But I want one with calculus.
The derivative of that function
At
C.
Thank you. This is it. And you could say, when is this useful? It is useful when I may not have these points. I may not know A and f of A and B and f of B. But if I know the slope of this line, I can tell you the average rate of change between these 2 points. If I have the 2 points, then what's the point of this? There is no point in determining f prime of C, because I can determine the average rate of change between A and B, and that's algebra. But I may sometimes I may not have these points, and I can still determine the average rate of change between A and B by determining f prime of C.
Will something like this be used in a function or in a question where we would receive like maybe a point and then?
It is possible you can, yes. So that you have 1 point, you have the derivative, and then you're asked to determine the other point. Excellent question, Reese. Thank you. So let's apply the MVT in a problem. On page 289. Number 11 caught my eye. We're given f of x equals natural log x, and we're given the interval 1, 4. Same conclusion, the same requirement, verify that the function satisfies the hypothesis of the mean value theorem and on the given interval, then find all numbers C that satisfy the conclusion of the mean value theorem. Okay, so number 1, I know how natural log function looks like. Remember, it's one of our friends. Obviously, on 1, 4, this is 1, and this is 4. Obviously, it's continuous and differentiable. So then f is continuous, on 1, 4. Number 2, f is differentiable at least on 1, 4. So now I have to determine, it's guaranteed that this there is a C, so by MVT there exists C, at least one, in the open interval 1, 4, such that, and remember, f prime of C equals f of 4 minus f of 1 over 4 minus 1. Okay, I have to find f of 1. I know f of 1 is 0. Natural log of 1. Natural log of 4 is simply natural log of 4. F prime of x, because I need this side as well, is 1 over x. So now I put everything together and create this equation and then solve for C. The left-hand side, 1 divided by C. The right-hand side is natural log 4 divided by 3. So this is a proportion you can cross multiply, but every time you have 1 divided by the variable, what we can do in a proportion is flip both sides. It doesn't matter, you can cross multiply, it's the same thing. So C equals 3 divided by natural log 4. And this better be between 1 and 4. So just to convince myself there is no error, I will just divide 3 by natural log 4 and make sure it's a number between 1 and 4, and it is 2.16. That's the mean value theorem. Any questions? Any questions? Should we look at another, or is this okay?
We can do another example of this.
Okay, sure. Would you like to choose, or I will?
I think you can.
Okay, number 10 then. F of x, x to the third, minus 3x plus 2, and the interval is -2, 2. Same question. Verify that the function satisfies the hypothesis of the mean value theorem on the given interval. Then find all numbers C that satisfy the conclusion of the mean value theorem. Okay. I have to write, this is a polynomial function, it's number 1. F is continuous on -2, 2 as a poly function. And number 2, F is differentiable on at least -2, 2 for the same reason as a poly. That's 14. Good. So therefore, by MVT, there exists a C, at least one, in the open interval -2, 2, such that f prime of C equals f of 2 minus f of -2 over 2 minus -2, which is 2 plus 2. So from here I have, this is an equation. You cannot use more than one equal symbol. So I have to find f of 2. I have to find f of -2. Okay. So 2 is 8 minus 6 plus 2, and that's 4. -2 is -8 plus 6 and plus 2, and that's 0. And I need more paper. Okay, so f prime of x, I lost my function, is 3x squared minus 3. Okay, so f prime of c will be 3c squared minus 3 equals f of 2 was 4 minus 0 divided by 4. Or 3c squared minus 3 equals 1, or 3c squared equals 4, or c squared equals 4/3. Now, what do I do to solve for c?
Square root.
Very good, thank you very much. So I get that c is plus or minus 2 over the square root of 3. And which one is in the interval -2, 2? Either both or none, and none is not possible because it's guaranteed by Rolle's theorem. So 2 divided by the square root of 3 must be a number between -2 and 2, and the other one is a number between -2 and 2. Here's an application. It just caught my eye. Number 24. Any questions on this problem?
As the answer, you would give both points just plus
Absolutely,
or minus.
yes.
Okay.
Yes, yes.
Okay.
So obviously there are 2 points on this graph whose rate of change or whose derivative will be the same. And equal to what? Equal to 1. That's our f prime. Our f prime is 1 at these points. So it'll be something like so here the tangent is 1. Here's the slope of the tangent is 1. And these are 2 points. 1 with c equals 2 over the square root of 3. And the other one with c equals -2 the square root of 3. But the same slope. Very good question. Is that okay? These have to be
Yes.
these have to be parallel, having
Yeah,
the same slope. Very good. Okay. I would like to look at 24 on page 289. Suppose that 3 is less than or equal to f prime of x, less than or equal to 5 for all x, they say. Show that 18 is less than or equal to f of 8 minus f of 2, and it's less than or equal to 30. Okay, so let's read the problem. We don't really have much to read, but it says, suppose that f prime, the derivative, is bounded from below by 3 and from above by 5 for all values of x, and show that f of 8 minus f of 2 is between 18 and 30. So this is a typical example that involves the mean value theorem because of what I see here. And obviously, I don't even have the function, right? So it doesn't say, but obviously the function has to be continuous and differentiable, because otherwise it will not have a derivative. It has a derivative at all times for all x, obviously must be continuous. So I can write those two. So number one, f continuous for all x, no doubt, because f prime exists and it's a number, it's squeezed if you want, or bounded by 3 and 5. So the function must be continuous for all x. And number two, the function must be differentiable also for all x, because that's what it says. So these are the hypotheses of the mean value theorem. Because this happens, then I will have to say there exists from here, by MVT, there exists at least a C in some interval, and we'll decide in a moment, such that f prime of C equals, and now I know what I want to use, and I know what interval I want to use. Can anyone give us an idea? Obviously, I'm going to want to have this in the numerator. Then what do I have to have in the denominator?
A minus 18.
Very good. Right? 8 minus 2.
Oops.
That's okay.
Yeah.
That's okay. That's okay. Right? F of 8 minus f of 2 over 8 minus 2, correct?
Yeah, I see that.
And then what is the interval then? It must be 2 comma 8. For this to be f of 8 minus f of 2 over 8 minus 2, this has to be 2 comma 8. So we have to find a C between 2 and 8, 2 comma 8, such that f prime of C is this. I'm also told that f prime of x, for any C, if you want, must be bounded. So this expression must be bounded as well. Because that's what this says. It says for any x, including this, the derivative is bounded between 3 and 5. Okay. So, but the derivative also equals this. As long as the function is continuous and differentiable, the mean value theorem is applicable. So then, in order to have f of 8 minus f of 2, since it's for all x, I can choose exactly what I'm interested in between 2 and 8. So because f prime is between 3 and 5, then this f prime, which equals this, must be also between 3 and 5. And what do you think will be the next step? Anyone? What should I do now as the final step, really? What do you think?
Why not multiply both sides by 6?
Say it again. Yes. And
Oh, I see.
and we showed exactly what we needed to. And this is all based or possible because of the mean value theorem. Any questions? Any questions? We have roughly, about 12 minutes, 13 minutes. We can continue or we can just work on a couple of problems. We can move on to 4.3 or just not and just go back and work on a couple of problems. What do you think?
I'm okay with doing more examples.
Okay.
Yeah, me too.
Very good. Let's go back to, I think this is 16. One other function caught my eye in 44 with critical numbers. 44 on page 281. We have f of x equals x to negative 2 natural log x. We're asked to find critical numbers. So let's work on this one for 1 minute. I'll just grab a cup of water. I forgot my bottle of water on the counter. Oh, it's empty, that's why. I'm back. Can anyone give us the derivative or anything?
The derivative just negative 2x.
Yes, so yes, you can write negative 2 x to negative 3 times natural log x plus x to negative 2 times
1 over x.
That's it. So this is the same with negative 2 natural log x over x cubed and plus 1 over x cubed, or negative 2 natural log x minus 1 over x cubed. I obviously realized that I could factor out x to negative 3, but it's the same if I just keep it in the denominator with a positive exponent. And then, of course, I will factor out negative 1 because I have negative 2 natural log x plus 1, which is negative 2 natural log x minus 1. And from the very beginning, I should establish the domain of this function. It's definitely 0 to infinity, because this function is the same with natural log x divided by x squared. X cannot be 0, of course, but natural log is defined on 0 to infinity anyway. So the function is not defined at 0. The derivative is not defined at 0. So 0 is not a critical number. So critical numbers will only come from this. from f prime of x being undefined? No. Because this function is undefined at 0, but so is the original function, so it doesn't change anything. So from here, a fraction is 0 only when?
Numerator is 0.
Correct. So then I have to write 2 natural log x minus 1 equals 0, or natural log x equals 1/2. And what do I do now? How do I find the solution?
Raise both sides to, but no, sorry, e to
Yes. So
natural log of x.
yes, e raised to 1/2 equals x, right? Or
Yes, sir.
or this. This is the critical number. But you know me, I want to find what type it is. I'm not happy to just say, okay, I found a critical number. But will it turn into a max or min? Not necessarily. It's not guaranteed. As long as the derivative changes sign, it will be. But if the derivative does not change sign here, it will not be a max min. So I would like then to study the sign. So this is x. This is f prime. This is f of x. Of course, the domain must be 0 to infinity, nothing else. I do have the square root of e, and I know the derivative is 0. I want to copy the derivative here. So we can discuss it because I need to study the sign. And I need to determine this value here. So natural log x is 1/2. So the top is 1/2. And the denominator is e. So this is 1 over 2e. So f, let me write it for you. F of the square root of e equals natural log of the square root of e divided by e. But this is 1/2. And I will know what type of point this is once I have the signs here. If it's positive, negative, then it's a max, local max. It will happen to be local, an absolute max as well too. But if this is negative and positive, then it's a minimum. It will also be, no, it will not be the absolute max because this is infinity. It will be, oh, I haven't studied the function yet. Anyway, so we'll see in a moment. Okay, so I am not going to plug in anything here because this is positive no matter what. I will only plug in here. I cannot plug in 0. The square root of e is more than 1. So 1 is here. So when I plug in 1, this is 0, minus, minus, positive. When I plug in 10, 10, natural log 10 minus 1. So 2, natural log 10, and then minus 1. I get a positive number, but there is a minus in front. So now it's absolutely guaranteed for this, the square root of e comma 1 over 2e to be what type of number?
Maximum.
Yes, local max. And since it does this, it's also an absolute. Yes, sorry, Reese, my apologies.
For 1 over 2e, it's fine.
How we got this one?
Yeah, I was curious, was it given in the problem?
No, I always have to determine the y value. So every time I have a critical number, if I don't determine the y value, I will not be able to tell you which point it is. I will only have the x coordinate, but not the y coordinate. So I plugged it in the original function because this is the function. And this is the derivative. So I plugged it in the original function. F of the square root of e is natural log the square root of e over the square root of e squared, which is e.
Okay.
And yes, and the square root, natural log of the square root of e is 1/2. So 1/2 divided by 2 is 1/2e. Any questions on this problem? We have about 4 minutes. Would you like to study the sign? I keep saying study the sign. I meant study the function on a closed interval.
Sure.
Okay, and then we'll stop. Number 62 on page 281. F of x equals x minus 2 tangent inverse x, and the interval is 0, 4. I'll get my table going. This is a different type of problem. It's asking us to find max, min of this function on a closed interval. I don't have to worry about the domain or anything. This is given to us, and it will not be a tricky question. The function is not defined, and I'm asking you to study it. Okay, so the first step we need to perform is find the derivative of this function. That's our first step. So f prime, the first function, x prime is 1 minus 2. And does anyone remember the derivative of arctangent?
Is that secant squared or is that a different number?
It's the inverse tangent, is the arctangent. Arctangent prime is 1/1 plus x squared. Is that okay? So then I need to multiply this. So I have 1 plus x squared minus 2 over 1 plus x squared. Is everything okay, everyone? Yes?
Yep.
Okay, so I continue simplifying it, and I get x squared minus 1 over x squared plus 1. I really, really like it. I really like it. Okay, so all I have now to realize is that there are two critical numbers. So from f prime of x being 0, from f prime of x being undefined, not possible. This is always defined. X squared plus 1 is never 0. So then we have x equals -1 and x equals 1 are critical numbers. And you can say, not so fast, your -1 is not in there. Okay, fine. And then I have to plug in 1 in the function to determine this value. Arctangent 1 is pi over 4, and this is 1. So f of pi over 4 is pi over 4. I'm sorry, I mean f of 1, that's what I mean. F of 1 is 1 minus 2 times pi over 4. Don't write this, I'm going to erase it. So this is 1 minus pi over 2, or 2 minus pi over 2. So it's going to be a negative number, but that's okay, right? So 2 minus pi divided by 2, that's exact. Okay, so I have to approximate this, I have to punch in 0 and I have to punch in 4 and determine those numbers. Because I'm studying the sign on a, I don't know why I kept saying the sign. I'm studying the function on a closed interval. Okay, so let's see. When I plug in 0, arctangent 0 is 0, so this is 0, so this is 0. And let me calculate this. I know I exceeded by 1 minute. You don't have to wait if you don't want to. So sorry. Okay, and divided by 2. It's negative 0.6 approximately. And when I plug in 4, I get 4 minus arctangent 4. And I got negative, so let me see if my mode, yeah. 2.7. So it appears that it decreases and it increases. Very easy to study the sign of this function because this is always positive. No problem there. In between solutions will be negative. So obviously that's the case. So remember, we are looking at y values. Here's 0. Here is negative 0.6. And here is 2.7. What do we conclude about 0, 0? What type of point is 0, 0? It cannot be local because it's at the endpoint of the interval. So 0, 0 is really nothing. It's not an absolute max. It's not an absolute min. Nothing. What will I say about 1, negative 0.6? It's definitely local minimum, but also absolute minimum. Absolute and local min. And what do we conclude about 4, 2.7? Is the absolute max, and it cannot be a local max.